I want to welcome everybody. My name is Alex Berg, the founder and CEO of Cratos Equipment. We specialize in battery-powered construction equipment, and today we're really grateful to have two fantastic speakers. They're going to go through short presentations to really talk about the future of job site safety, and I'll kind of moderate and ask some questions as we go along, because we want to make sure that everybody gets as much value out of this. There's going to be some incredible information from both of our speakers. So on your screen, the two gentlemen that are with me, although I'm kind of with them here. We have Dr. G. Scott Earnest. Scott is an associate director for construction safety and health at NIOSH. And prior to joining the Office of Construction Safety and Health, Scott was engineering branch chief in NIOSH Division of Applied Research and Technology from 2005 until 2015. He has over 70 peer-reviewed publications and technical reports. He began his career as an active duty commissioned officer with the U.S. Army Corps of Engineers. He's a registered PE, certified safety professional with a Master of Science and PhD degrees in industrial mechanical engineering. So if I would have just stayed in school a couple more years, I would have what he has. And then correct me if I'm wrong, Ignacy. I hope I'm gonna nail the last name. I promise. So Ignacy Puskzkiewicz, he's a senior director with JLG. He works at JLG Industries. It constitutes access segment of Oshkosh Corporation. He's senior director responsible for research and future technologies applicable to JLG products and industrial design across all platforms. He's got 38 years of experience in research and development of mobile off-highway equipment and vehicles, and 25 years of designing products with JLG. So lots of fantastic information coming from his side as well. So we will start off with Dr. Ernst. He's got a great presentation of some of the things that NIOSH is doing, some of the research that they have done, and what the future of job site safety looks like. So Dr. Ernst, I will let you take it away from here.
Okay, great. Thank you, Alex. It's good to be with everyone, and looking forward to talking about some of the things we're doing in this important area. Let me bring my slides up and try to share my screen. This will just take a second. Okay, so can you see my slides?
Yes. So and I do want to say there is a Q&A. So if you do have some questions, if you're watching, go ahead, type them in. I'll monitor them, so we can try and make this interactive as we go.
Okay, thank you. So I'll go ahead and get started. I wanted to just begin by explaining to everybody what the difference is between NIOSH and our sister agency, OSHA. NIOSH is a research agency. It's really the sole institute within the federal government that is focused on conducting occupational safety and health research. We fall under the Department of Health and Human Services and the Center for Disease Control within the federal government. And our sister agency, OSHA, is in the Department of Labor, and they're responsible for standard setting and enforcement. But we work very closely together on all issues pertaining to safety and health in general, and for the construction industry as well. So in terms of the NIOSH construction program, it's really important because the construction industry is a very hazardous industry. Consistently, about 20% of work-related deaths occur in the construction industry. So if you look at the total number of workers across the country, construction represents about 6% of all U.S. workers, but about 17% of the fatalities that are occurring. So there's really a disproportionate risk there in the construction industry. The mission of our program is to eliminate construction fatalities and injuries and illness through a focused program of research and prevention. And so again, we're not only focused on the safety hazards, but we also look at health hazards as well. And we do that by considering BNI, which stands for burden, need, and impact. Burden represents the number of workers and the severity of the hazard to them, whether it's a fatality or musculoskeletal disorder or hearing loss prevention. Need is how important is it for the industry and for the workers, and then impact. Even though we're a research agency, we want to make sure that the work that we do is impactful And we don't want to just publish papers and have it sit on the desk. We want it to really make a difference in terms of the lives of workers. So I wanted to start off with just showing some data about the hazards in the construction industry. This is data that was developed by CPWR. It's the National Construction Center that NIOSH funds. And this information is available on their website. But the graph on the left shows the number of fatalities in the construction industry going back to 1992. So 1992 to 2017. And you can see, in any given year, there's anywhere from, around 800 fatalities up to about 1,300 fatalities. And, there was obviously a dip in this time period, and that corresponds to the economic recession that our country went through, and when a lot fewer workers were actually working. So there's a dip, and then it's gone back up. The good thing is that if you look at this red line, that's the rate of fatalities, and the rate of fatalities has been dropping generally for some time. But again, I talked about how hazardous the industry is. This graph over on the right-hand side is a bar chart showing a comparison between industries in terms of the number of fatalities. This is data from 2017. But as you can see, unfortunately, construction is at the very top, where in 2017, there were over 1,000 fatalities, representing about 20% of all fatalities in the U.S. that occurred on the job. That's followed by services, transportation, agriculture, and then manufacturing. Mining is down here at the bottom. It only had 113 fatalities, still way too many, but there's a lot fewer miners in the country than there is construction workers. The other thing I wanted to mention is what's called the Focus 4 hazards in the construction industry. I'm not sure how many of you are familiar with what that is, but it represents falls, caught in or between objects, struck bys. Struck bys are real common, on work zones. If you have a vehicle that goes into the work zone and hits a construction worker, the falls, that's really common in roofing. Falling off of roofs while putting houses, and then electrocution. So between the four of those hazards, that represents about 60% of all fatalities in any given year. And this graph shows data from 1992 to 2017. So the portion in red is the falls, which is by far the largest on any given year. And then that's followed by struck by, electrocution, and then caught in or between. And if you add them up in each given year, obviously it's a very large number. That gives you a better sense of the hazards and what their impact is on the industry and the workers. Now I wanted to turn to talk about some of the areas that NIOSH has focused its efforts on really over the last decade. And there's 5 primary areas that we've done work in. One is respirable crystalline silica, noise and hearing loss prevention, musculoskeletal disorders and vibration, work zone safety, and then fall prevention. So we've put quite a bit of effort and research into each of those areas. The work that's been done has been internal NIOSH staff, as well as we're funding universities and, again, collaborating with CPWR. And in terms of the research that we do, we're always looking at, what do we need to do to control or mitigate this hazard? And the way we do that is we consider what's called the hierarchy of controls. And that's what this graph represents on the right-hand side. So at the top is elimination, followed by substitution, engineering controls, administrative controls, and PPE. So we really consider all of those. Generally speaking, the higher you are on this list or near the top is the most effective way to control a hazard. As you go down towards the bottom, it's much more dependent on human behavior and is less effective. So I wanted to talk a little bit about preventing falls to a lower level, or preventing falls to a lower level. Basically, one of the big things we've done over the last decade is we organize the Falls Campaign. The National Falls Campaign, we've done this in conjunction with our sector council, with OSHA, and with CPWR. It's an annual event, typically occurs the first week of May, and it's basically encouraging construction companies to take time out and communicate with their workers about steps that they can take to prevent falls, how to work safely and prevent the serious injuries and fatalities that can occur from working at elevation. And so we've actually set up 3 different websites that provides a tremendous amount of information. If you're not familiar with this, I recommend that you check these websites out. The top one, the Stop Construction Falls website, is the primary site for the Falls campaign. Then there's also the site below, which is a NIOSH site, and then the OSHA site. And they're all three linked. But there's a lot of really great information there that's available to help with conducting stand-downs within your own company. Okay, this is a photo from several years ago. It was at the MGM Grand construction site in Washington, D.C. for one of our Falls campaign stand-downs. There was over 2,000 construction workers in attendance at this stand-down. But again, we've reached over the last decade, we've reached several million workers through the Falls campaign effort and the stand-downs. We've also developed a lot of supporting materials, and each year we have a different theme. Recently, we had a theme about making it personal and providing stories of how fall prevention can save lives. Because one of the issues is a lot of people in construction, especially in smaller companies, they don't think it's ever going to happen to them. And unfortunately, it's the small companies where the highest rate and highest number of fatalities and injuries occur. So we really wanted to try to provide information about how falls are occurring in the industry and things that can be done to prevent them. Another area that we've been working on has to do with hard hats or helmets in the construction industry and how to make them safer. And again, over the last 100 years, there's been a big transformation. This is over on the left-hand side here. This is kind of an image of hard hat that was used in the early 19th century, and then the more modern, almost like a rock climbing helmet manufactured by Cask. We've been conducting a whole series of studies to look at the design of helmets and make recommendations on how to improve their overall performance. Because hard hats, if they're designed well, if they stay on during a fall, can help to significantly reduce traumatic brain injury and even prevent fatalities for certain types of falls. We've also done quite a bit of work on silica and silica exposures. This is a picture from a project we did on asphalt milling. As part of this project, we worked with the National Asphalt Paving Association, the Federal Highway Administration, the Association of Equipment Manufacturers, the laborers, the operating engineers, and we looked at engineering controls to reduce exposure to silica that's produced during asphalt milling operations. And many of you are probably aware, or most of you are probably aware, that OSHA regulated silica. They reduced the overall permissible exposure limit a number of years ago. And NIOSH conducted a lot of work to support the OSHA standard setting process. There's something called Table 1 in that standard that outlines 18 different tasks that if you follow the table and do it properly, you don't have to conduct compliance sampling for the permissible exposure limit. You don't have to conduct exposure assessments. So it just makes it much more simple for workers in the construction industry to be in compliance with the new standard for silica. And then after they initially released the standard, they've been working on expanding it. And so we've been collecting data on a lot of different control systems to support OSHA in expansion of Table 1, because Table 1 has been fairly popular. As I had mentioned previously, we've also done a lot of work on noise and hearing loss prevention. It's the most common work-related illness in the U.S. Each year, there's about 22 million workers that encounter hazardous noise, and the construction industry is no exception to that. There's a lot of very loud noise sources in the construction industry, and so we've really tried to focus on work to develop quieter equipment. And so what we call that is we call it Buy Quiet, or prevention through design. And so back in 2015, we began an initiative to encourage buying quiet and to encourage manufacturers to really look at the noise of the equipment that they produce and ways to reduce the noise so that there's quieter equipment that's available on the market. And we're continuing to work in this area and do research. We've done work on pneumatic nail guns, jackhammers, circular saws. Some of this has been done internally, and also working with a number of different universities on reducing noise from construction equipment. We've also done quite a bit of work on musculoskeletal disorders. That's also a very important hazard in the construction industry. Musculoskeletal disorders can be caused by high physical exertion, awkward postures, as is shown in this image of some construction workers that are tying rebar by hand, prolonged static exertion, repetitive tasks. So MSDs and prevention of MSDs is another important area. A lot of the work we've done on this topic has to do with overhead drilling, looking at the design of equipment to do both overhead drilling and then also horizontal drilling. A lot of the equipment that's used is extremely heavy, and if it's done manually, it can really take a tremendous toll on the construction worker's body. And so we've done a lot of work on that. And then I just wanted to try to wrap things up to talk about a little bit about the evolution of construction. Construction is obviously a rapidly changing industry, and safety has dramatically improved from many, many years ago. This is an image from New York City, where safety obviously was a whole lot less important than what it is today. So what does the future look like? Well, key researchers and theorists in the field of robotics say automated machines are about to migrate from factories and manufacturing facilities to building and construction sites as a result of rapid technological advances, which enable them to perform increasingly complex tasks. So there's a lot going on. Some of the key issues in the construction industry are productivity, certainty and delivery of a job, shortages in skills, and data transparency. And each one of those issues, there's the whole issue of automation robotics can play an important role in trying to help address those for the industry. So NIOSH has a whole effort going on, more than just focused on construction, but really for across many industries. But it's about the future of work and emerging technologies. And so we've got work going on related to nanotechnology and how that can impact the construction workforce, advanced materials, additive manufacturing, artificial intelligence and machine learning, sensing technologies, modeling and simulations. So just a whole variety of different areas that we're conducting work in and trying to look at how these technologies, how changes in the workforce can have a positive impact on worker safety and health. This next slide just shows some images of some of the areas where we're conducting research specific to construction. So over here on the top left is exoskeletons. I don't know if you're familiar with exoskeletons, but we're doing a lot of work in this area. It's basically sort of like a Iron Man suit that you wear and can really help reduce wear and tear on the body because it helps to actually lift heavy equipment and hold it in place. We're also doing a lot of work on drones and how drones can positively impact the construction workforce. We've got an active project on demolition robots and how they can reduce injuries, and also looking at situations where there are some injuries that are occurring because of the use of these if it's not being done safely. And then driverless vehicles, again, automation robotics. This is a robot that's being used for bricklaying, and then one over here for putting down some brick pavement. So again, we have a lot of work going on in this area. This is kind of just a brief summary of some of the things that we're doing, and that wraps up my my summary of safety and health in the construction industry and the future of work.
That was fantastic. Thank you for all the really good information. I wrote down a couple things that I quickly would like to ask you some questions about. So the first thing you talked about, which kind of I'm sure Ignacy will talk about a little bit as well, was the beginning of May you do a stand down week, right? What have you seen the impact over the years with that as far as falls, and maybe even Ignacy can touch on that as well, of what JLG is doing as far as stand down week and how they, we're trying to see less ladders on job sites around the country.
Yeah, I mean, it's a really important event for us. Again, we partner with OSHA and CPWR and really just try to get the word out on how to work safely. We have a work group on our sector council that's chaired by a guy named Tom Shanahan, who's the vice president with the roofers. And, we conduct webinars during stand down week to just provide information about how to do it safely, how to wear body harnesses, how to make sure they fit properly, just a whole wide variety of different issues. related to falls and fall prevention in the construction industry. And we've reached, at this point, millions and millions of workers, mostly in the U.S., but some of it's international at this point. And, on a year-to-year basis, there was a really nice drop in the total number of fall fatalities a year ago. Unfortunately, in this past year, it looked like some of the numbers had gone back up. And so we're kind of redoubling our efforts now and trying to look at root causes of falls and fall prevention in the industry. And we're working with there's an ANSI committee on falls, and we're working closely with them, and CPWR is actually taking the lead on this effort. But we're really trying to focus on root causes and what can be done to prevent those root causes when it comes to falls from elevation.
Yeah, there's been some changes in the ANSI standards for fall prevention recently, and machines are constantly being updated, and I don't want to say future-proofed, but we're getting better and better, and getting smarter about the way we're constructing machines and how we're putting them on the job site. So, go ahead.
If I could just briefly tie this into the future of work, the other thing that we're doing is we are getting research proposals on a variety of topics that tie in the future of work to fall prevention. So one example would be robotic roofing. There's universities that are looking at the application of robots to put roofs on houses. That is, obviously if you got a robot that's putting the roof on, and the robot falls off, that's a whole lot different than a human being falling off the top of a roof. Another area with drones, we're looking at the use of drones for doing inspections at elevation. Why send a human being up to the top of a telecommunication tower to do an inspection if you can just fly a drone up there and do the inspection for them? So there's lots of things like that related to the future of work and advanced technologies that could come to play a role in preventing some of the injuries and fatalities that we're seeing in the industry.
Sure. One thing that you touched on that's super interesting for us and our industry, we deal a lot with contractors that are working indoors, demolition contractors and concrete cutters specifically. And I think Hilti just came out, or they're working on a machine that is based off of BIM technology that drills overhead holes. So you touched on it briefly, but what is your research showing around the exoskeletons and drilling overhead holes and horizontal drilling, and what that does, and what the future looks like for that, of how technology can change that on a job site?
Yeah, well, it can really take a significant wear and tear on the body of a construction worker if they're doing a lot of overhead drilling. So we've tested out a variety of different types of equipment that'll really help with just holding the equipment in place and being mobile. And there's even robots now that can do that for construction workers too. So there are a lot of technologies that can come to bear to help reduce the hazards for construction workers. And Hilti, we've actually worked with them on a number of different projects. They're doing some really, really good things when it comes to development of equipment that is safer than just your traditional equipment. We work with them on silica controls, for example. So lots of good things coming out of Hilti.
And my last question is a little bit around the hearing loss, because it's not something that a lot of people take as serious on a job site as you do with hard hats or eyeglasses, but hearing is a huge portion of PPE and what's necessary to keep a job site safe. I just jotted down something really quickly on part of your slides. It said 50% of workers suffer some type of hearing loss. What do you see the future of what your research is showing of that, and how we can really adjust in the future?
Well, a lot of our effort when it comes to addressing all hazards, but also including hearing loss, is trying to apply the hierarchy of controls to the hazard at hand. So when we're talking about noise created from construction equipment, we would prefer to see quieter equipment being used, or being manufactured for that matter. It's really kind of a prevention through design approach. And so we're putting a lot of emphasis on that, and trying to encourage manufacturers to design out the hazards because the problem is, I mean, hearing protection, earplugs or earmuffs, if they're worn properly, they can really make a big difference. But you got to do that, every single day. You got to put it in properly. You have to have a good fit. You should typically be fit tested for them. And if you don't do all those things, they may not be very effective. So if you can get to the hazard at the source by designing it out, which we need partnerships with manufacturers to do that, that can really make a big difference. But yeah, you're absolutely right. Hearing loss doesn't get the attention of falls because, a lot of people don't even recognize it until they're older in life, and then their hearing is gone and it isn't going to come back. But it is a significant hazard and have quality of life issues for the worker and for their families.
Thank you for all the fantastic information. And Ignacy is going to come on and tell us all the massive boom lifts that JLG produces. They're changing them all from diesel to battery, so they're all going to be quiet, and they're rolling them all out next year, right?
Yes, absolutely. Can I get started?
Yeah, absolutely.
All right, let me share. Okay. So my name is Ignacy Puskzkiewicz. I apologize. I think Alex was introducing me when I got very flaky connection, so I don't know what was said, but I'm with JLG Industries. I'm involved with access industries since 1996 when I joined JLG. But all my career, I was involved with off-highway construction and mining equipment. And today I would like to talk about technology supporting job site safety from access equipment perspective. And I think two things are interesting about access equipment. One is that really this whole industry got started to improve safety on the job site and allow people to work safely at height and productively at height. And the second one, that sometimes we don't think about access equipment as a construction equipment, even if those machines are present on every job site, and in some cases in multiple units, reaching hundreds of units per job site. What we understand under access equipment, those are the mobile elevated work platforms, which are placing people to work at height. And we also talk about telehandlers because they are designed to place materials so this work can be done. Looking at changes to the approach of the worksite safety, we need to realize that those changes are driven by several factors. One is our regulations, another are customers. This standard drove changes to the machines and the business across the industry, and also changed responsibilities of various participants. It affected the machine style elevated work platforms. Those systems were known and required in Europe for many years, but this new standard forced implementation of them in United States. The load sensing systems prevent operation of overloaded machines. They are based on measuring the force of the load on the platform either directly or indirectly by measuring pressure in hydraulic cylinders and calculating the force based on the position of the platform. You may think that allowing workers to take more tools and material to do work at height and still being safe and operating the machine. The load sensing systems on the work platforms are domained and are required by regulations. However, for telehandlers, the requirement to know the load conditions are not driven by regulations, but they are developed because the new technology allows us to offer functionality benefiting productivity and safety of the operator. With load moment management indicator systems, operator does not need to rely on his subjective estimate, but it's given actual data about the load and information how far and high this load can be placed. One of the traditional challenges for the industry is collision and crashing danger avoidance when operating machines from the platform. You know, really the falls from the platform or tip overs of the platforms are not the major or the main factors in fatal accidents working with access equipment. There is much more incidents involving crashing when operator is not reacting to his surroundings or her surroundings. Industry has developed passive systems which are providing enhanced operator control station protection, which minimize the severity on the incidents, because when the operator is pushed against the platform control box, machine will stop and in some cases reverse operation. But we are also observing a lot of work and evolution of enhanced detection systems that are intended to prevent contact between operator or the platform and object in the surrounding. Those technologies are important to minimize the danger of harm to the operator and also minimize the damage to the structures around the machines. And those can be very elaborate and expensive to repair structures too. This technology is rapidly evolving and improving, and the process of this improvement will continue into the future. I will take a risk and try to play the video, which is the animation of the enhanced detection system installed on the platform of the boom lift. You can have different levels of system with different numbers of sensors. Those sensors are sensing what around the machine and allow either operation or provide warning or the stop zone. And if operator is in the stop zone, he has to take another action to allow machine to operate slowly so he can get closer to the place he needs to work. Those sensors are being turned on in the direction of machine movement to avoid unnecessary false alarms, as you can see on this video. Similar system is developed also and offered for the scissor lifts. So we talked about environmental awareness and collision avoidance around the platform of the machine working at height. But similar issues are related to improving visibility and collision avoidance related to drive and the chassis. Here is again the area where we are observing rapid technology development. We can provide situational awareness because we can deploy the sensor technology developed by automotive industry for autonomous driving or robotics industry or automated guided vehicles. And we can expect rapid development and fusion of different sensing technologies and fusion of the data to really provide the bubble of safety around moving machines. Another interesting development is with more sophisticated control systems of the machines and preventing the falls, we can offer fall arrest systems, which traditionally area work platforms were designed for people to work from the platform, but it is not always possible. Sometimes you have to step on the roof or on the wing of aircraft or other object you are working on at height. So the fall arrest systems allow you to step out from the platform, have some freedom of movement, but in the same time being protecting from falls. More advanced control systems are allowing also different approach to how machines are rated. Traditionally, machines were rated assuming the worst combination of conditions. They were rated to operate on certain tilt angle to accommodate an even surface, assuming that machine is fully elevated and it's fully loaded. This resulted in very much restrictive working conditions, where, for example, on the scissor lifts, it is quite common to have tilt, or the slope of the surface machine is operating on, limited to 1.5 or 2.5 degrees. With the new variable tilt technology, machine can measure using load sensing the load on the platform, and of course all machines have tilt sensors, and we can develop algorithms which are telling the operator at what loading conditions to what height he can operate the machine, or vice versa. If he wants to achieve certain height, what load he can take. And we were talking about fall from ladders, which are representing one of the highest safety incidents on construction job sites. Industry is still evolving. Our industry started from machines allowing people to work at 40 feet and above. Now, many OEMs are looking into low-level access. Those are methods and new machines, new concept of the machines to provide methods of doing work at limited heights, but the machines can be easily disassembled into easy to transport light components. And those solutions are still evolving. It's one of the interesting characteristics of our industry, access industry, that it is still evolving. New concept of machines are coming to market. There is a lot of innovation happening, especially in this low-level access, and new products are being offered to replace or at least minimize the use of ladders. So, in summary, access industry is offering variety of solutions focused on safety, but we are also considering productivity and cost of ownership. Safety is leading theme for machine designers, but job site safety is complex issue, which involves machines, their selection for the job site preparation and organization, and finally proper training of people involved in performing work at height. We are working to see new technologies integrated into our industry, and we believe that this trend is accelerating according to the available technology and needs of machine owners and users. Thank you for your attention.
Awesome. Thank you very much. So just a couple quick questions that I had, and might be able to tie this back into what Dr. Ernst was talking about as well in some ways. What do you, the load rating was really interesting, the load management system. How readily available is that, and is that something that is now something that's standard on your machines, and it's something that we're seeing more and more, or is that something that's new and coming out in the future?
So for the aerial work platforms, for booms and scissors, load sensing system is today standard equipment required by regulations, by ANSI standards. So all newly produced boom lifts and scissor lifts are equipped with load sensing system, which measures the actual load on the platform and prevents operation of the machine if platform is overloaded. For telehandlers in US, those systems are not required by regulations, but we are seeing a lot of interest from customers and users who want to help operators to do jobs safely and productively.
Seems like an incredible value add for someone that can measure the load rating out extended away from the machine at different heights, to have machine learning be able to tell you exactly what the unit is and is not capable of doing at different angles and different lengths away from the chassis of the machine.
Absolutely. Those were challenging technologies to develop, but they are available today either as a standard or as an option, depending on application.
And you talked a little bit at the end, you talked about low-level access and how that's changing probably on a weekly basis in this country, especially probably with the research that NIOSH is doing and the feedback that we're all getting from the field. What's the future hold with JLG, and what's really the next step in low-level access?
So I think we are seeing a lot of interest. We are seeing a lot of growth in this area. JLG acquired a company called Power Towers in UK. Power Towers is one of the leaders, and UK market is one of the leading markets for low-level access because of the regulations. Basically, in UK, you cannot use ladders on the job sites. So there was a lot of, and still is a lot of developments. We are translating those applications, adopting those machines to North American rental market requirements, and as you said, there is a lot of activity, a lot of developments, and we believe those trends will continue.
Sure, it's the number one cause of job site incidents is falls, right? So
yes.
If we go off I think the top thing on Dr. Ernst's chart was removing, right? So if we're able to remove ladders from the job site, it reduces that risk significantly.
Right. Provide more stable base, allow the device which you can safely use both hands to do the work, which is not properly, it cannot be done properly according to training on the ladder. So you can use both hands, you can be more effective, you can be safer and prevent it from falling.
Sure. And my last question, and then I guess we can open it up to any questions from those that are attending. What does the future look like from JLG as far as noise restrictions with machines? We've seen there's been a big push for battery technology, and we've seen some larger machines, of course, the machines that are working indoors, low-level access lifts, some 19-foot scissor lifts have been electric for quite some time and run off of batteries. But what does it look like for machines that are typically outdoors, even like this knuckle boom that's in your photo that with the screen share?
So it's absolutely, you are right. We have two ranges of products: industrial products, which are used mostly inside, and those machines were electrified many years ago in the 80s and 90s. We are seeing as an industry the trend for electric machines to move to the construction sites, and there are two drivers for this. One is elimination of the CO2 emissions, and the second is noise. People, when they are getting electrified or electric machines on the construction site, are immediately recognizing the benefits that, the neighbors are not complaining, they can work longer. In many cases, they can work at night because machine is quiet, it's not polluting the noise. So this is really, the trend to electrify the machine started from emission regulations, but noise is becoming a very important factor in acceptance of those technologies.
Yeah, we're seeing it more and more from our side as well. It's the working indoors is first and foremost for our small equipment. That's great, but we're seeing more and more the noise requirements and the long-term service and maintenance costs is becoming a real benefit for our customers.
Absolutely.
All right, and I'd love to open it up for some questions. I don't see anything that's in the Q&A, but if there's anybody that has any questions, please feel free. I think there's if there's a way, maybe Laura, if there's a way that we can open it up for questions. I think all the microphones are on listen only mode, but love to see if there's anybody that has any questions from the audience.
We can certainly allow people to chime in. Yes.
Okay. I guess if there's no questions, I mean, we're coming up here on 45 minutes of total time, which is kind of a perfect timing for this.
Could I ask a question? Can you guys hear me?
Yeah, absolutely.
This one's gonna be for Scott. Have you guys been doing research on strictly battery use machines like indoors and stuff like that?
I guess I'm just curious. What type of research are you curious about?
Just on like safety and are like people adapting over to the battery power more and more as time goes on? Have you noticed that, like people starting to use them a lot more on job sites? Like,
yeah, we are definitely seeing more and more batteries getting used on job sites. There's a lot of benefits to it. I mean, one area that we've done work in the past, sort of ties in with this a little bit, is carbon monoxide issues. So if you've got equipment that's operating, with an engine, a gasoline powered engine, or some other type of fuel, liquid propane, there's always a potential for carbon monoxide to be produced, especially if it's being used in an indoor environment, if the engine gets out of tune. And so, battery power, you don't have that problem. And the types of batteries that are available now are much more effective than what they had been in the past, and provide a lot of power for equipment. And so there's a lot of, real positive aspects of battery powered equipment for indoor use.
Yep. And I did go to school for safety over at Keene State. And have you been seeing people in charge of safety and stuff trying to push that battery powered and on the indoor stuff and like confined spaces and whatnot?
Yeah, I mean, it's definitely an issue. And, sort of like what I had talked about previously with the whole hierarchy of controls, if you can eliminate the hazard at the source by, eliminating some like combustion type engine with a battery source, it can make a big difference in terms of preventing carbon monoxide issues. And, there's other benefits as well from battery use.
Thank you very much.
Awesome. Great question. Anybody else have a question for Ignacy or Scott? All right. Well, again, thank you, gentlemen. Thank you, both of you, for taking some time out today to give these two great presentations. Hopefully, those that are attending, this has been recorded, so we'll be able to send it out. Hopefully can walk away with some good ideas of what the future holds for construction sites. So again, my name is Alex Berg. I want to thank Dr. Scott Ernst and Ignacy Puskzkiewicz from JLG, Dr. Ernst from NIOSH, and everybody, please be safe out there. And we want to make sure everybody goes to work in the morning and comes home at night. So thank you very much. Have a great rest of your day.
Thanks, Alex. Thanks, everyone.
Thanks.